Welcome to the project demonstration of solar grid based charging station for electric vehicle. In this project we are using one step down transformer, one step up transformer and PIC microcontroller, two rectifiers here we can see, and 12 volts 1 amp battery, and also using a MOSFET board as a inverter, and also using AC load with a AC bulb, the 0 watt bulb, and also using a mini rectifier, and also using solar panel. So we are using a multimeter for the measuring the voltage from here. So we are giving the, if we want to charge this battery through electrically, so we will use this power cable. So it takes 230 volts of power and it will be given to the primary of the winding, and the secondary of the winding it gives 12 volts. So up to 12 volts it will be step down. That step down AC voltage will be given to this rectifier. Here we can see rectifier. We know that rectifier converts AC to DC. So that DC voltage will be the DC side will be connected to this 12 volts 1 amp battery. 12 volts 2 amp battery. So this is a 2 amp battery. Now here we can see it is connected to the battery. So if we give the power supply here, so here we can see the light indication, which means it is connected DC and it is giving the charging to this battery also. If we don't want to charge this battery, so just remove this connection. And also we are using solar panel to charge this battery, 12 volts 2 amp battery. So here we can see we are giving the solar panel output to this rectifier input. So through rectifier output, through rectifier we will connect the battery to here. So it will charge through solar. So if we remove this one, so we can see the light indication, it will be not glow. If we give the connection here, so light will be glow. Due to low sunlight, it is giving a low amount of power. If we place in a sunlight, it will give high amount of power, then it will be, light will be glow very high. So one doubt will be raised in our mind that solar plate will be generated DC power supply. Again, why we are giving to the input for the rectifier? We know the rectifier converts AC to DC, but here rectifier will act as a polarity corrector and protect from the reverse current. So in a sunlight it will generate a more voltage, then it will go to the battery. So whenever there is no sunlight, then it will be a high polarity, then the reverse voltage will be come to the solar panel, because voltage will be flow from high polarity to low polarity. So the voltage will be come reverse to this solar panel, then it will be damaged. That's why we are for the protection of the solar panel we are using the rectifier. In rectifier it consists of diodes which have so we know that diode function, it allows only forward voltage, it doesn't allow reverse voltage. So the forward voltage is a solar voltage and the reverse voltage is battery voltage, so it doesn't allow reverse voltage. And also it is act as a polarity corrector. If I change the connections from negative to positive or positive to negative, it gives only positive negative, but doesn't change any negative positive terminals. In this way, the solar panel will be interfaced with this battery for the charging purpose. So if we want to on the AC load, we need to switch on this switch. So if we on the power supply, it will be, so through 2 volts 2 amp battery we are giving this power supply to this PIC microcontroller. Here we can see PIC microcontroller, and also here we can see regulator. Its number is 7085. So PIC microcontroller will work on the 5 volts power supply only, but we are giving the 2 volts power supply. To step down this 12 volts to 5 volts power supply, we are using regulator. So it takes 12 volts power supply and will give output of 5 volts. That 5 volts power supply will be utilized by this PIC microcontroller. So when we on the power supply, first PIC microcontroller will be on. After that it will generate a pulses. That pulses will be given to this MOSFET board. Then this MOSFET board act as a inverter. So each MOSFET board will be triggered by this PIC microcontroller. So here we can see so the pulses will be generated by C3 and C2 pin connections. It will see. So here I am on in the power supply. So you can see it is first on. After that this bulb will be on. Now it is working on the 230 volts of power supply. So let me explain this circuit. So it is taking the 12 volts power supply and we are giving the pulses to this MOSFET to act as an inverter, and this MOSFET will be convert this DC 12 volts to AC. So these two MOSFET will be converts from DC to AC. That AC will be given to this connection. So it will take 12 volts of DC power supply and it will be generated 12 volts AC power supply. That AC power supply will be given to this step up transformer. Here we can see step up transformer. For the secondary side we are connecting the 12 volts AC and we will be step up to 230 volts. That 230 volts will be, so 12 volts to 230 volts will be boost this transformer. So here we can see the primary side. The primary side is connected to the bulb, and also here we can see the mini rectifier. So we want to check the voltage from this one. We are using a mini rectifier. It takes input from this bulb side and calculated by this multimeter. We have to set DC side. Here we can see DC side because it is connected to the rectifier. So now it is connected to the DC side voltage. Now if we on the power supply, so here we can see, so we need to set as a 200 volts. So here we can see it is nearly generating a 71.6 voltage. In this way the direct voltage will be converted into a AC voltage. So basically in direct voltage we have only one line. In the alternating current we have a positive cycle and negative cycle. That positive cycle will be generated by these transistors and the negative cycle will be generated by this transistor. So based on that, if this positive and negative cycle will be generated by this MOSFETs. So MOSFET will be triggered by this. Here we can see these connections. These connections will be come from PIC microcontroller. In this way, this part will be works. Thanks for the watching.